Hello there, welcome for our lesson. Today we are going to look at the minerals and the environment. And from the previous lessons, we had already looked at the structure of the earth. By the end of these lessons, we'll be able to look at the various parts. Example, that is, we'll be looking at the structure of the earth, and then we'll also be able to look at the minerals. Then in the next lesson, we shall be looking at the weathering and erosion as we proceed. But because today we are going to look at the minerals and the environment, we'll base on the first thing, that is the structure of the earth. We look at shortly the structure of the earth so that we gain the basic information over which we'll be able to apply them in the lessons of the minerals. We had learned that the earth is made up of three principal parts of the structure, and that one is the core, the mantle, and the crust. Today, we have picked a little part of the structure of the earth, but we have left the core. We have only pictured the upper mantle. This is the upper mantle. And then the lithosphere. And then it has what we call the crusts. Because of this part, we will only review few things about the mantle as we had looked at in the previous lesson. In the previous lesson, we look at the mantle covers around 80% of the earth's volume. That is the mantle. Now remember, the mantle is divided also into two. We have the upper mantle and the lower mantle. And the mantle, from the previous lesson, we learned that it extends up to 2,885 kilometers of thickness. We also learned that it has a variation of temperature that range between 1,000 to 2,500 degrees Celsius. And most of the rocks that are found in the mantle, we learned that they are semi-molten, especially in the upper mantle. They are plastic in nature. For example, you expose a plastic in a molten form, it will flow just naturally in that manner. And the inner mantle is made up of the rigid rocks, which cannot be moved. That is about the previous lessons on the mantle. Therefore, the mantle, we have only picked out the upper mantle. The upper mantle is separated by the lithosphere. And the lithosphere, when we come to the continental crust, the lithosphere is a bordering discontinuity that borders the oceanic crust and the continental crust. Therefore, on the continental crust, that is now where we will be exploiting much more of the minerals. And the continental crust is made up of two parts. We have one part is called the seal, and another one is simmer. Seal is less dense than simmer because of the mineral content it has. Seal has a component mineral of silicon and aluminum, which are relatively less denser than the magnesium elements. That is silicon and magnesium elements that are found on the second part of the continental crust. Therefore, we are going to look into the continental crust as part of seal and simmer, which makes up the continental crust. But now the continental crust itself, it is bordered by the oceanic crust. An oceanic crust is a layer that also harbors the hydrosphere or the water body, where we'll have on top of the oceanic crust, we will have something like an ocean or just a large water body mass, where this large water body mass, sometimes it borders the continental crust now, where people stays or they have erected their habitations, such as their homes and buildings. They are actually based on the continental crust, which is now the first part of the crust where it's found on the Earth's surface. As we have been able to look at the structure of the Earth in this manner, therefore, where are the minerals found? Minerals are mostly found on the continental crust. And during the volcanic eruption, you will find that now from the deep core into the interior of the Earth, where there is the core and the upper mantle, because of that is enormous heat energy that is periodically released into the core of the Earth, because we learned that it has a temperature ranges between 3,000 to 5,000 degrees centigrade, it makes those rocks to melt, and as they melt, they become in molten state. We refer to them as magma. Magma is a molten state of a rock. And this rock, in its molten state, it bears also some minerals. Therefore, during eruption, when, for example, I will use this part as a magma chamber. This is where there's a chamber, as a magma chamber. During eruption, the molten material, that is magma, will penetrate through the crevices. Sometimes it may cool and solidifies within the earth crust and forming what we call intrusive rocks or intrusive features, that is within the earth crust. But when the molten material is ejected out onto the earth surface now, that's where the continental crust is, it now begin to flow. As it flows, it will create layers of lava, and those lava also carries some minerals that will soon, upon erosion, will be exposed on earth's surface, and then the mineral content that are found within these materials of lava, we'll find them as minerals already exposed on earth's surface on erosion. But when they are not embedded in this material, they can still be found within the earth crust. And that is where we have to look at the structure of the earth. Therefore, we'll be able to understand where are the minerals found. Now, after understanding this part, then we'll be able to move on to the minerals. What is then a mineral? What is a mineral? We'll be able to look at that question then as we answer it. What is a mineral? A mineral is a naturally occurring inorganic substance that is found beneath or on the earth crust, and it has a definite chemical composition. We have been able to see that it is a naturally occurring inorganic substance a naturally occurring inorganic substance that is found beneath or onto the earth's surface or the earth crust with a definite shape, with a definite chemical, definite chemical composition. For today, that will be our understanding of a mineral. We were looking at a mineral. We have learned that a mineral is a naturally occurring inorganic substance that is found beneath or onto the earth crust with a definite chemical composition. That is our understanding of the mineral. Therefore, beneath the earth's surface, we are learning that a mineral can be found below the earth crust, can also be found on the earth crust, that is on the earth's surface now, because we have learned that sometime during volcanic eruption, that magma or the lava flow, when it flows, it may carry some mineral content in it. As it solidifies and cools, those minerals may be exposed on Earth's surface upon erosion process, of which we'll be able to look at it in the next. Now, all rocks are made up of minerals, and most commonly minerals are found in solid materials that are on Earth's surface. We have also learned that minerals are found in the rocks. Therefore, all rocks may contain, minerals. The rocks may contain minerals, but only a few which are very common, they are found separately, not from the rocks. That is the mineral. And we have over 4,000 types of minerals on Earth. Some of them are very rare, while others are very common. Out of the 4,000 kinds of mineral, we have very few that are very common and are known to us and even the scientists. But most of the minerals are rare. That is, they cannot easily be found. Let's move on and look at the characteristics of the minerals. What are the characteristics of mineral? Characteristics of mineral. Having understood the knowledge of what is a mineral, then it must be somewhere in your mind coming up with a certain characteristic. For example, look at your ring. If you have a ring on your hands, or some people who have the rings on their hands, you'll be able to find out on that ring there's some elements that is denoted on it. And that element is a characteristic of a mineral. That is, can give it a very typical characteristic, and we'll be able to know what type of characteristic is it. Therefore, we are identifying that minerals have various characteristics because They are found in the nature. They are naturally inorganic substances that are found on Earth's surface. And because some of these minerals have value, they have also different characteristics. One of the characteristics that most minerals have distinct shape. Most minerals have distinct shape. You'll find that there are some minerals have a distinct shape, very unique shape, while others have no form or they do not have any shape. We are still looking at the characteristic of minerals, and one of the characteristics that most minerals have distinct shape. For example, diamond. Diamond is a mineral that has this shape, and basically it is octahedral shape, and it also carries the tetrahedral shape, that is when it is bonded. We are looking at the second characteristic that most minerals, or some minerals, have different degree of hardness. Some minerals have different degree of hardness. Some minerals have different degree of hardness. Still, when we come to the hardness of the mineral, it comes also from the rock. And the hardest rock, we learned that it is diamond. Diamond, basing on Mohs scale of hardness, it is placed scale number 10, and it is one of the most hardest mineral, and because it has a very lasting degree of hardness. That make it also another characteristic of the mineral. Some minerals, they crystallize in shape. That is number 3. Some minerals crystallize. They crystallize in different shape. As we have been able to look at they are crystallized in shape and color. Because already we have looked at the shape, we look at the color. For example, copper is a mineral. When it still have some impurities, ranging on the degree of impurity. It may be orange or it may be red. When, depending on the level of impurities that are embedded in on the copper. But a mineral like quartz, a pure mineral, is colorless in its form. Quartz is a colorless mineral when it is very pure. But when it contains some impurities, it may be blue, it may be black, or sometimes it may be so dumpy or purple, depending on the level of impurities that it has. Therefore, we have been able to look at the 3 characteristics of mineral as we are continuing. Number 4 characteristic is that some minerals have different cleavage. Some minerals have different cleavage. They have different cleavage. And cleavage is an ability of a mineral to be malleable, and an ability also for it to take a shape that it can be changed from one shape to another. That is the cleavage. Cleavage, or we have learned that some minerals have different cleavage. For example, this is a type of a mineral that is made of quartz. It is a glass, and when you look at it, you try to scrub it against the wall or against other rock, it leaves a streak, or it may break. That breaking is the resistance for it to be worn out very quickly. Instead, it just break in form of the shape of that mineral. Now, that is the ability of a mineral to break easily, or a splitting. If it does not split, sometimes it may leave what we call streak. That is characteristic number 4 about the mineral. Lastly, we'll also be looking at minerals have different degree of luster. Luster. Different degree of luster. And luster is an ability of a mineral being able to be seen in the light. You'll discover that some minerals have shiny elements. Their luster is very shiny. Others are dull. Others cannot easily be seen where there is dim light. Therefore, that is the ability of the mineral having the luster. And lastly is being malleable. As you try to heat some minerals, they just may, they have an elastic ability, and an elastic ability is to be molded into a distinct shape. For example, the mineral of aluminium. Then we are also looking at another characteristic of being malleable. And malleable is a characteristic of mineral having elastic form. For example, an elastic band can easily stretch and come back again to its normal position. Therefore, I was using a mineral like an elastic ability. It can be easily molded to take a given shape that you desire. For example, aluminium can easily be molded, into the form, in a form or the shape that you desire. For example, you can twist aluminium and make some rings. You can mold an aluminium and then form what we call the iron rooftops, especially the corrugated iron rooftops. This ability of them being molded in this shape, therefore it gives a distinct characteristic of being malleable, and therefore they have those characteristics. And there are also some other characteristic of which I wanted to give it as a test, that you can add some 4 more characteristic of minerals at your own time using another source of characteristic of minerals. Because of time, I want us to move to the next part of the minerals. How are minerals formed? Because we have to exhaust this part. How are the minerals formed? In other words, we are looking at the formation of minerals. How are minerals formed? Minerals, once they are formed, mostly they occur in ores. And an ore is just a mixture of other minerals. It is still not refined. It can bear around a mixture of several minerals. Occurring together in a clump. But when they are refined, then that means we have removed some impurities. Then we'll be able to see how it is formed. But now in its natural state, it is in ore. And as they tend to occur in this ore, there are several mixture of other minerals that are concentrated. We look at the concentration percentage of a given mineral in this ore. That is what will give its localized name according to the type of the mineral that is found in and the chemical composition that is found in this. And in the process of this ore occurring with concentrated several minerals, it is called geologic process. Therefore, minerals are formed in the process of geologic. And these geologic processes, they include various types of process under which these minerals are formed. For example, one of the geologic process over which mineral can be formed is magmatic deposit. We have the magmatic deposits. And during volcanic eruption, as the magma cools, it will be solidified either on Earth's surface or beneath the Earth's surface. In the magma, as I said, the magma may contain some mineral deposits. That is during volcanic eruption. And as it cools and it solidifies, it may lead to some rocks or some minerals placed or deposited in a magmatic way on the Earth's surface or into the Earth's surface. And this mineral, as they occur at the bottom of the magma chamber, we'll be able to see the magma that is now during volcanic eruption. And we learned that magma is a molten state of rocks on the Earth's surface. As it erupts, remember, this is a molten state of magma. And in this state, it has become in fluid. It is actually in a fluid which is also viscous. Depending on the degree of viscosity, it can easily flow out containing some minerals which will be deposited. As long as embedded in the rocks. That is magma deposition. That is the process of geologic process, which you call it magma deposition, that allows the mineral that are contained in the magma, when they flow out, it may be cooling and solidify. Therefore, the mineral may be deposited somewhere in the bedding planes or in the magma chamber, where the lava, it can be the magma lava is actually cooling down and solidifying. Therefore, it may be deposited around here. And this one is a magma deposit. And then sometime there may be a follow-up of different layers of lava in that manner. The geologic process explains that. There is also another way in which the mineral can be formed. That is the process number 2. Process number 2, that is hydrothermal deposit. The hydrothermal deposits. When you look at hydrothermal deposits, still referring back to eruption period, but mostly this occurs in water. Hydro means water. But when you see this geologic process, that is the hot aqueous. The hot aqueous solution, which carries some mineral particles or mineral elements, and mostly it is in solution form. It may flow following the streams of water. And as it follows the streams of water, it is being transported from the original point where it was, and then it will be deposited. It will be deposited in a different place, and that is hydrothermal deposits. In other words, it follows the aqueous solution. There are some minerals which can easily dissolve in water. Following the streams of water, they are transported. Remember, water can transport some minerals in dissolved matter. Therefore, it will be deposited somewhere as precipitate. Or in the process of precipitation. Therefore, for example, the halite is a good example of a mineral that is formed in this process. The hot aqueous solution follows the streams of water. It will be transported in solution form, and then eventually it will be deposited in a quieter water in the process of precipitation. That's now where the rate of evaporation is very high. Therefore, as the vapor evaporates, it leaves behind the precipitate. This precipitate will be deposited and form what we call a halite. Is a mineral which is now there. It can be found there, and it can be explored for other valuable uses. Let's look at another process of geologic process. That is number 3, mechanical accumulation. We have mechanical accumulation. That is the process over which a mineral may also be formed. And in other words, this one is now called general deposition. Mechanical accumulation can also be referred to deposition, that is on Earth's surface, where there is a lot of water bodies have been accumulated, especially when we look at the very quieter water bodies. Or when we look at the river may carry some minerals as it flows. And then these minerals, depending on the speed of the river, these minerals may be carried over a long distance, and then they are not in solution form, but these are just in pebbles or fragments. For example, the fragments of silver and gold. They are still carried by the water, and then in the process where the river will meet, it will reduce its speed of flowing because of the sharp bend. You will find that some minerals may be deposited around this side because the speed has reduced. And when this river, when the water level reduces, you will find that these minerals are deposited. We call them the mineral deposits. Will be found along the meanders or the bends. And this bends shows that a river has almost reached its old stage, and the speed at which the river is now, or the water is flowing, has reduced. Therefore, the deposit, or whatever the load it had carried, it now begin to offload it by depositing it. And that is what we call mechanical accumulation. And they can be deposited elsewhere from one point to another. Sometimes it can be deposited in large water bodies as it is. We have another process. It is called the beach placer. Called the beach placer. And this one occurs when the waves. Now, in the ocean, there are waves. And these waves, they produce the currents over which, when the water is flowing, it may produce what we call the onshore drifts. It may produce what we call the drifts along the shore. And they act parallel to the beach, where the highest wave will go and act parallel on the beach, and as the water strikes this area, this is where there is a cliff, this is just a coastal area where there is a beach, and this represents the water. As the waves comes and hits the beach, it may, because of the mineral solution, or depending on the rock that is found along the shore, if it is very soft rock, for example, it may cut a little bit, and when the water drifts along again into the ocean, it may have deposited or it might have placed some mineral deposits along this path. We call them the placer beach. And mostly the type of mineral that are placed in this process, the beach placer perhaps is the major source of a mineral that is called ilmenite.
5 minutes.
Yes. Ilmenite, which is a major source. It is an ilmenite and rhyolic. Rutile mineral, not rhyolic. It's a rutile mineral, which are the major sources of titanium. There are major sources of the titanium minerals, which is mostly extracted because of its beneficial use. And I hope you are able to understand the use of this mineral. And lastly, we will have to look at the placer. We have looked at the beach placer. Lastly, we will be looking at the placer deposit. That is placer deposits. This involves liberating minerals. We call it the placer deposit. Placer deposits involves liberating the minerals such as gold and silver by mechanical erosion. Liberating the minerals by mechanical erosion. And the kind of mineral that can easily be liberated by mechanical erosion, we have gold and silver. Along, they can be transported down the stream depending on the area of their occurrence, because some can be embedded in the bedding planes. They can also be carried down the stream, and they can be deposited or they can be placed, especially in the more sharper bends, where they can be stratified or can be covered by other deposits. Just to cover them, they can be covered by other deposits and making them either hidden in the bedding planes of the stratified or the strata, depending on the rock, the bedding rocks where they are deposited. Because when we look at the Mohs scale, it has classified minerals in different levels. When we look at the Mohs scale of hardness, the scale of hardness of rock can also be established scientifically, and it was created in 1822 by a geologist, mineralogist, is called the geologist, and mineralogist. Whose name is Sir Frederick Mohs. that is in 1822, is the first scientist or mineralogist, also was a geologist, who discovered this scale, and therefore it is called after his name. We refer to as the Mohs Scale of hardness. When we look at this scale, it is used to measure the hardness and the surface durability of the minerals and even some stones. Shortly, as we'll be able to explore this scale, we'll be able to place some minerals in different levels. We'll be able to look at the Mohs scale of hardness, and as we place more minerals, depending on the different degree of hardness, the surface durability, especially the original part was the stones. In the next lesson, as we meet.